Hola, buenos días, comunidad de Perú de Java. El día de hoy empezamos la JConf 2022. En este momento vamos a iniciar con la primera charla del día. Estamos con Ixchel Ruiz. Ella ha desarrollado herramientas de software y aplicaciones desde el año 2000. Sus intereses incluyen Java, lenguajes dinámicos, tecnologías del lado del cliente, DevSecOps y testing. Y es Java Champion, Groundbreaker Ambassador, Superfrog, Hacker Garden Enthusiast, Open Source Advocate, Public Speaker y mentor. Y Chell viaja alrededor del mundo y algunas veces de manera virtual, como lo está haciendo el día de hoy con nosotros, para compartir su conocimiento. Y es una de las, digamos, no sé si decir metas, pero es algo de lo que principalmente a ella le gusta hacer. Así que te dejo, Ixchel, para que puedas compartir con nosotros el día de hoy tu charla.
Muchísimas gracias por esa introducción. Y estoy un poquito, bueno, la plática se llama DevOps for Java Developers. Está el título en inglés y de hecho ofrecí darla en español, pero al parecer se quedó en inglés. Pero como me mencionaron ahorita, pues soy mexicana, entonces hablo pues español, obviamente. Y bueno, muchísimas gracias por tenerme en esta conferencia. Estoy súper feliz, súper orgullosa de platicar sobre todo para comunidades latinoamericanas. Voy a cambiar inglés porque si la anunciaron en inglés, prefiero darla en inglés. En cualquier momento me pueden poner comentarios y yo cambio en el lenguaje que ustedes quieran. Entonces, empecemos. DevOps for Java developers, and I'm super happy to be speaking here at JConf Peru 2022, and I hope this conference is as good for you as it is for me, and that is awesome. And the actual title that I usually use is, Are We There Yet? Because DevOps has come like in the last 15 years, it has taken more importance in our industry. But are we there yet? And that's actually a great question. So a little bit about me. As I said before, I'm from Mexico. I live in Switzerland. I'm a Java champion. I work for Ixchel, and I participate and collaborate in a lot of open source foundations. For example, the CDF, the OpenSSF, the CNCF, and I have collaborated in several books. For example, the latest one is DevOps Tools for Java Developers. So if you, I urge you to have a look, obviously read it and leave us a review. And let's go inside this particular session, DevOps in Java. So let's start with the DevOps part. What it is, what are the important remarks about DevOps? And one of the important remarks for us as developers is, well, how important is DevOps in the job market? And I was looking for statistics in PayScale for Peru, but they only had for software developers. They didn't have for DevOps engineers. So I left the ones that I have, for example, for Mexico, my home country. And for example, the average salary of a DevOps engineer is 434,000, and the average is 415,000 pesos. And in the US, we have a similar situation, 98,000 for DevOps engineer, and the average for a software engineer in the US is 88,000. Germany, a country very close to mine, again, the DevOps engineers is almost 60,000, and the software engineer salary is going to be below. So my whole point here was DevOps engineers are being paid more nowadays on average. So keep that in mind if you decide to learn more about DevOps. So you play that kind of role in your development team. The other thing that we should talk about when we are talking about DevOps is the state of affairs. How are we? Like, why is this important? Is this going to be more important? Where we are? What are the companies thinking about it? So I will present a little bit of information based on the State of DevOps report of 2021 made by Puppet, and also the latest one from DORA report, the State of DevOps report. And this was developed by Google, most of it. So DevOps is so important to organizations because it improved the software delivery, the operational and the organizational performance. That is why, and it's measured. That is why it's so attractive for institutions and organizations to say we need, we want, we will implement DevOps in our organizations. So the four metrics, and this is the important part where I said that it is so ingrained in the mind of management, because these four metrics are very enticing for them. So they will actually increase or show the throughput of the development of applications through the organization, and also the stability, because it doesn't matter how much we release out there if it's our software is not stable or it's not delivering what it's important to. So what are these metrics? The deployment frequency. How frequently can we deploy? And by this, I mean, we shouldn't be deploying every single minute of the day if it's not needed. But what we need to know is that this frequency is achievable with a certain level of quality. Lead time for changes. Since we notice there is a problem, to actually change it to minimize or fix that error. What is that? The change failure rate and time to restore a service. So they are going to show us how resilient, how fast, or how well we develop software. And as you can see, if the different organizations are going to show different trends depending on their level of implementation of DevOps in their industry. If it's low, well, they are not releasing that frequent. If they are medium in the adoption of DevOps processes and mechanisms and methods, well, it's going to be between once per week and once per month. And if you are in a highly organization that has implemented a lot of DevOps methodology and processes, well, you can deploy on demand with the same confidence and the same quality. So as you can see, this is one of the reasons, like this particular graph, it's slide, it's going to be why organizations want to not only adopt it, but move as quickly as possible to the high adoption level of DevOps methodology, practices, and tools. And one of the other sides, like what happens if we are successful in this transformation of DevOps in our organization? Well, here I present the case of Anime, and you probably know it, the people that are aware of the US market. And for example, in 2012, when they decided to start this journey, they have only 10 teams using agile techniques. They release every 9 to 18 months. They had a very challenging ecosystem because it was very, very polyglot. They have a lot of programming languages and they had different tools in those programming languages, a lot of applications, and over 18,000 open source components. By the time that they concreted or finalized their journey, their quality measured by critical defects analyzed in the tool, regardless of the programming language, was improved between 30 and 48%. The productivity in terms of how many deliveries they could do in the same amount of time increased 28%. And the cadence of the release that they were able to do was 21 times more. That means over 19,000 builds per month with half of the previous staffing. And as we saw, they improved even the quality of the software that they were releasing and deploying. So these are, by the numbers, really interesting stories about how it can help our organization. Now, let's talk the other side of this equation, DevOps and Java. So we are actually, for Java developers, we are in such a good position. I'm not saying that it's the perfect position, but our programming language, our infrastructure is so well, and it has been there for so many times that it's very, very mature. So it is important that in every single phase of the development and execution and operations, we get as much information as possible. That is one of the ideas of DevOps. Acquire as many information, tighten our loops, enrich the information that we have, and react faster, because that's what we want. We want to increase the quality. We want to deliver more features every single release, also improve the quality of our code, either by refactoring, etc., etc. And if you already have seen this particular graph, this is the traditional one for DevOps, you see that releasing our software is a never-ending process between coding and releasing, testing, etc., etc. And every single one of these particular stages will and can provide us with information. Now, other three amazing keywords that you will hear nowadays, and you have been hearing for the last decade, are DevOps, DevSecOps, and shift left. So the DevOps started in 2007 and 2008, and it at that time was born of the frustration because there was such a dysfunction between developers and operating the ops teams. We will create something and say, well, this is ready to be deployed. And we will send it even by email to our ops team and say, okay, deploy it in our machines. And they were like, how, where, how, like what? And the operations teams had a really difficult time putting this, maintaining it, making it run, checking the performance, etc., etc. And on the other hand, as developers, we were not aware or so aware of the different configuration that we could expose. We didn't know about the challenges. We didn't know anything about what happened during operations. We didn't. We were completely blind to that particular stage, and the operations teams were frustrated because they didn't know how this software was created. They sometimes didn't know how it should be well deployed, and they had that responsibility. If you want to hear more about how this started, there is a really nice book, The Phoenix Project. It was in 2013. It's a novel, so it's very interesting. And there's the other one. This is because this is from the perspective of management, and the other one is from the perspective of the developer. But I will only show you this because this is good starting point. Okay, so the DevOps methodology, it's more about culture. It's increasing the transparency, the communication, and collaboration between the different teams. As I said, the main one was developers and the ops teams. And it is shifting a little bit the responsibilities. We developers build it, we should know how to run it. Granted, we will not run it in production, but we should know how to run it, even our staging environments. So by having all this feedback in terms of building and executing it, even staging environments, staging like production environments, we will get a lot of feedback and improve how it's performing, what should we do to try to abstract as many things as possible to make it more easy. And of course, because we don't like to do repetitive things one and after the other, probably we will increase the automation. DevSecOps. DevSecOps is only this idea of this exactly same process, but what we're going to try is to include more security practices. And the security practices include running in several stages of our software development cycle, different tools, for example, for static application security testing and composition analysis. So for example, this is the first one is checking that in our code or the source code, there is no weaknesses or insecure coding practices. In the composition analysis, we run this kind of tools to detect known software components, such as open source or third-party libraries, and identify vulnerabilities with that. The dynamic application security testing, those are running on runtime. This enables an outside-in approach to testing applications for exploitable conditions that are not easily detected during the static state. The web application firewalls monitors traffic at the application level and detect potential attacks and attempts to exploit vulnerabilities. So there are different tools that are listening to everything that happens, for example, in every single endpoint to detect if we are generating an incorrect answer or if we are getting incorrect requests, or more problematic than incorrect is security related kind of communication over there. Container imaging scanning tools. Well, nowadays we are using containers for development, for distribution and deployment. So containers are a really important part now of our development process and even our release process. So we need to understand where are they coming from and what is there. What is there at the base level, and what is there when we create a container image. So the latest one, the last one, software cloud security posture management, is only to check that if we have misconfigurations in the cloud infrastructure, because probably your industry or your company is thinking about more resiliency, and that means that different vendors to increase the availability of the services that you are providing or deploying on the cloud. If you have different providers, then, well, you are diminishing the risks of really being offline if some of the, like, Google goes down or Amazon goes down or Microsoft goes down. So, but that also increases the complexity, because now you have to make sure that the configuration, even between different vendors, it is equivalent, that you are not granting more rights or different kind of configuration of expected behavior for different vendors. So now we need to check this all the time. That's the whole point of DevOps. And finally, the third keyword that we have, shift left. And every single DevOps engineer will actually have to know this, and every company will ask you, have you shift left? Where are you? What tools are you using here? Well, shift left only means actually bringing testing and security measures into code development process early, really early, not at the end. Like, for example, we will code something and we add dependencies and suddenly we get quality assurance or compliance saying, this list of dependencies that you have licenses that are not compliant with our policies, and you're like, oh my god, so I need to find a different alternative for this particular libraries. Or, oh, these are the list of vulnerabilities that you had problems with. We cannot accept that you're using this particular version of this particular library. So as you can see, this is too late. So what the organizations want is, we don't wait until quality assurance or compliance is coming to our desk and saying, no, it's too late, it's too expensive. So the idea is to bring them as soon as possible into the hands of the development. And I will show you how or what tools are doing that in a more seamless way with developers. So testing and security. Those are the two different pillars that we want to increase with DevSecOps and shift left. And those two topics are super important, and even more right now. If you, as DevOps has been for the last decade, there is another architectural style that we may have been encouraged to adopt or even tempted to change. And this is microservices. So, and this is one of the definitions that I like the most. This is by Martin Fowler. And he says that, and the part that I want to emphasize here is that they can be independently deployable and may be written in different programming languages. So, small services, and every single one of these services can have their own life cycle and even different programming languages. So, what is this for me is all the different challenges that we had for improving the quality of software that we build and releasing more valuable features in every single release are multiplied from requirements and specifications, documentation, architecture, testing, security, automation to cross-team collaboration. All these concerns are multiplied by the number of microservices or by the number of teams that are in charge of as multiple number of microservices. So micro, mini, or small services, I'm actually not going to go into the definition and the boundaries of what makes it each of one of them, can be written in different languages, evolving at different rates. Now we have a different kind of concern. We have a concern about this version of service A should be run with this version of service B. And we have ranges here. So there is a lot of more things happening if you are using or adopting this architectural style. And my comment to every single customer that comes and say, I want to move to microservices, my first question is, are you adopting DevOps methodologies? And if the answer is no, my suggestion is they do first or start both transformation as soon as possible, because one with the other will be a headache, guaranteed. So let's talk about tools. Finally, something tangible that you can take away with you. In the terms of security, when I was mentioning like moving as left as possible, I want to present you Frogbot. Frogbot is a Git bot, and you probably have heard about the Pandabot. Yes, that's good. I'm actually very, very happy that you have heard about that, if you have. But let me tell you that Frogbot is the big brother. What do I say is the big brother? Well, first of all, if you create a pull request, for example, GitHub, GitLab, Bitbucket, or several other Git repositories, as soon as you modify your build file, it will actually trigger a security scan and will tell you there are some problems with it, or it's okay. And when it's telling you there are some problems with it, it will tell you the severity, what version is affected, and the fixed version. And it also can run without creating a pull request. We'll check your build and we'll create a pull request to tell you exactly that. But when I say that we're the big brothers, it's because when management comes and tell me, Ixchel, we should have more applications running in terms of security for our developers. And the first thing that I said is like, if I run this particular application or this particular assessment on my software or my dependencies, it will return me with 100 different security issues. And when I have 100 or 1,000, there is no way I can address every single one of them. And some of them are actually not even affecting either our particular software circumstances. So one of the things that I love about this is you can create different watches and different policies, and different watches and these different policies will act as filters. So the information that I get back on the security scan advisory, it's going to be focused to what I need. Not the entire universe, but the entire universe that is important to me. So that is awesome. The second tool that I should recommend it to you is this one, is the Docker Desktop extension. Since last year or this year, no, 2021, they created the extension part of Docker. So JFrog has its own Docker Desktop extension. Again, if you go to JFrog and start for free, you get a free tier. With this free tier, you actually can configure all these different tools that I'm mentioning, and you will get the benefits without doing anything except for saying for getting your free tier instance, and you don't even need a credit card for your free tier instance. So you can benefit right now from advanced security and compliance, advanced security features and really interesting functionality without waiting for anything. So as you see, you scan the different images and you will get similar report. And what you can see here is even our reports are a consolidation of different public databases for vulnerabilities, plus our security team is always enhancing and trying to verify if and provide more information based on our clients' information to say, well, this is indeed qualified as this, but these are the preconditions. So you may be not affected or so harshly affected by this particular issue. The last one that I want to show you in this regard is this. This is, for example, a screenshot of an IDE. Actually, my IDE, I use IDEA. And here you can see that I have a Maven project file, a POM file. This is a Java Maven, very basic application. And I'm adding a dependency in my POM to a version that we know there has some issues. And as soon as you can see, I'm typing that in the lower part where the plugin window is displayed, you can see that it's showing me the exact same information. So this is happening even before you're doing a pull request or even before you push something into your remote repository. And in the Java world, we have adopted the microservice architectural style with Gusto. So, and that's good. That's good. And we are very, very happy that we have all these frameworks ready for us. For example, Spring Boot, Quarkus, Micronaut, Wizard, among others. As I mentioned before, the JVM, it's a robust platform and the Java ecosystem is very mature. So for example, on the testing side, we have libraries like JUnit, Hamcrest, Mockito, AssertJ, or Rest Assured, that it's all being used outside or from the get-go. But I will tell you about my favorite ones, and I will go fast because we have a lot of material here. WireMock is one of my favorite ones because it is a simulator and it's a mock server. And what is more important for me, it's super flexible. You can configure it with Java. You can use JSON to generate the different mocks or stops. There is a record and playback. One thing that I love is there is a simulation of faults. So whenever you are creating an endpoint, you can start creating your mock on those endpoints and you start delivering with even simulation of faults, which means that you are going to push your front end team to start thinking about the scenarios where things don't go right. And it is so easy to use. I will skip that. Rest Assured. Rest Assured is a very easy way to simplifying using REST. For example, it has authentication. You can specify request data, path parameters, cookie headers, multi-value parameters, verify that response data have the same thing. So this is really easy to consume and to create. Java and working with XML and it's JSON, and it's not the most friendly thing to use, but it uses Groovy. So Groovy, it's delightful to do this kind of stuff. So please have a look, use it. There, like for example, Quarkus actually uses Rest Assure as part of their main libraries for testing. Oh my God, this project, I have been in love for the last 5 or 6 years, and I fell in love because it saved my life, my professional life, more than once. Everything that you can run in a container, you can start using as with test containers. And for creating tests, it is amazing. For creating text, for example, with the real database, this is it. Stop using in-memory databases. Stop using H2DB. Start using the right databases. And fear not, if the test fails, you won't have zombie containers there. They're actually going to die after your test finish, and liberating all the resources. You don't have conflicts with different ports. You don't have conflicts with names. This beautiful tool will make it super easy. And for example, you don't have to use health checks. Like, you start your Postgres container and have your bash script. Like, are you there yet? Can I send you my script for creating my database, for my schema, or any starting data? No, everything is controlled in a professional adult way. Anyway, test containers, have a look. And even though I promote so much testing is always based, and it is bound by what we think it's going to happen out there or can happen. So at the end of the day, I'm sad to say the following. It doesn't matter. Well, actually, there is a correlation, but even if we have a healthy number of unit integration contract, that is consumer and provider test, UI end-to-end, REST API acceptance, and explanatory test, we are still thinking inside the boundaries of our imagination. And out there, things tend to be a little bit different. So, for example, this is typical thing. We test our applications in a very sanitized environment. We are very close to our I don't know, the most incredible good machines, very, very close to the data center, so there is no latency, everything runs particularly fantastic. But then the reality where our users are maybe is not in the same conditions. So we have to think about that, and we now need to know what is happening in that case. So we end up testing in production. I know, sounds totally bad, totally terrible. So I propose you to use the different word. We're going to monitor our applications in production. Monitoring is crucial for analyzing long-term trends, provides information on how the services are growing and how they're being utilized. On the other hand, observability, this was born in control theory, measures how well you can understand a system's internal states from external outputs. Observability uses instrumentation to provide insights that aid monitoring. An observable system allows us to understand and measure the internal finding easily and figure out the cause from the effects. So observability has 3 pillars. Traces, because now if you're thinking about microservices and then everything is like exploded, everything is in different places, everything can happen at different time. No longer it's linear. So it tracks the progression of a single request, called a trace, and it's handled by services that make up an application. So a request may be initiated by a user or an application. And distributed tracing is a form of tracing that traverses processes, networked as security boundaries. So a trace is a tree of spans. And what is a span? Is each unit of work in a trace is called a span. Spans are objects that represent the work being done by individual services or component as it flows through the system. So it's like, hey, I passed through here. This is how I was at the beginning. And then every single part of this process of this service will add something, say, oh, yes, I saw you. And this is how you change or something like that. So those are traces. The other pillar is the metric. And a metric is a measurement about a service, capture or runtime. And logically, the moment of capturing one of these measurements is known as a metric. And this event consists not only in the measurement itself, but the time that it was captured and all the associated data. Logs. A log is a timestamp text record, either structured, usually the recommendation, or unstructured with metadata. And logs, we have been doing this for far too long, so I don't have to explain you the log. And let's talk about even more tools that you can use right now. So remember when I told you that I believe in open source and promoting standards in the industry? So how we make it easy for us developers to build this kind of solutions that are going to be easy to change, or it actually take into consideration the concerns about being resilient, being based on the standard, etc., etc. Here it enters the Cloud Native Computer Foundation, the CNCF. And what they are aiming here is to seek the drive for adoption of technologies and techniques, but sustaining an ecosystem of open source vendor neutral projects. And probably you will have already worked with some of the applications in the CNCF. For example, one of the the first one to be graduated from incubation was Kubernetes. So today, talking about Kubernetes is almost a de facto in our industry, at default. So as I said, inside the security and orchestration, you have Kubernetes, which was the first project to be graduated. If you go to the CNCF, you can click on the different projects that are in incubation or graduation, and you will see like all the stats about when was it created, the language, etc., etc. So for observability analysis, these are the other options. And as you can see, there are clear cards and dark cards. The dark cards means that they are not open source, they're probably a commercial solution, while the clear cards, they are either open source, and some of them will say that they are in the incubation process or graduated. For example, Prometheus. And for tracing, you probably are very aware of Jagger or Zipkin. Jagger, it's very famous. It's written in Go. Zipkin is also famous as it's written in Java. And what I want you to have into your mind is OpenTelemetry. OpenTelemetry is going to be very, very important in the near future with different I will answer, Javier. I will answer in a few seconds about that. Let me finish this part. And fluently with logging. So logging is, as I said, we will have different services providing different logging. So now we need to, in a way, consolidate them and start like processing. And in this category, I suggest you to have a look to Grafana Loki, because it's what Prometheus is for monitoring. Loki is for logging. So Prometheus is an open source monitoring system developed by engineers at SoundCloud in 2012, and was the second project to be accepted and the second project to graduate it. I told you about open metrics and open telemetry that are really important for you or for us in the industry to start looking at. Open metrics creates an open standard for transmitting cloud-native metrics at scale. This was run from Prometheus, so they extracted it and created a standard. And it's a wire format, independent of any particular transfer for that format. It is expected to be consumed on a regular basis and be meaningful over successful expositions. Open telemetry, it is more than just a new way to visualize data across applications. This project aims to change how we use instrumentation without requiring a change in monitoring tools. It's a collection of tools and features designed to measure software performance. And this is new, but not so new, because this is the amalgamation between two other open source projects, which was Open Tracing and Open Census. And Open Census was the internal traceability platform for Google that later on evolved into open source standard. So it provides APIs and SDKs, among other tools, to measure and collect telemetry data for distributed and cloud-native applications. And it's really easy to add to your projects. So the CNCF provides you with this particular landscape. And to tell you the truth, it's a little bit scary. And they realized that it was super scary, so they created the cloud-native trail map. And the cloud-native trail map, it's only a recipe that keeps telling you if you're going in your journey about microservices, or you want, yes, actually about microservices monthly, is these are the things that you have to start considering: containerization, CI/CD, orchestration, observability analysis, service mesh, networking, distributed database, messaging, container runtime, and software distribution. And we made it. I was a little bit worried I will run out of time and not from material. So I will return to some of the questions because I saw some of the questions. Okay, so the first question that I have here is Javier. No me quedó del todo claro a qué se refiere específicamente shift left. Es incluir un stage de prueba de rendimiento dentro del mapa de despliegue. No. Bueno, shift left se va a ver reflejado en diferentes formas, pero shift left es todas las consideraciones y sobre todo dos de las consideraciones más importantes, que es seguridad y pruebas, moverlas más cerca. Y no estoy hablando de las pruebas que nosotros corríamos, las que nosotros creamos, de unidad, de integración, de end-to-end. No, sino esa consideración de las pruebas que, por decir, el equipo de Quality and Assurance de pruebas creaba hacia nosotros. Esas están un poquito más complicadas y normalmente sí necesitamos al equipo de Q&A de ayudarnos. Pero lo de seguridad es lo que les estaba mostrando, por decir, con las diferentes herramientas. Es antes de hacer un release, antes de crear nuestros empaquetados de software, es estar seguros que las versiones que estamos corriendo no tienen vulnerabilidades conocidas. Es esta idea de correr este tipo de herramientas de análisis estático de código, de análisis dinámico, verificar las vulnerabilidades presentes en las dependencias. Todo eso, en lugar de hacerlo después de que hicimos el release y ahora Q&A agarra nuestros releases y empieza a probarlos para verificar que la funcionalidad que nosotros prometimos en ese particular release está presente, y para los diferentes niveles de servicio es tan rápido como prometimos, y sobre todo no estamos generando ningún conflicto entre las librerías de los componentes que están al interior del proyecto o del programa, y también no estamos introduciendo ningún riesgo de seguridad. Entonces, shift left es toda esta idea de no esperarnos hasta quality assurance, no esperarnos hasta compliance para recibir este feedback, esta retroalimentación, sino hacerlo lo más al principio posible. Will you please elaborate in the difference between observability and monitoring? Primero, observabilidad. Monitoring es, monitoreo es lo que habíamos estado haciendo. De repente se nos cae un servidor. Generábamos una cuenta de un correo y decíamos, ups, se cayó. Eso es monitoreo, es estar teniendo señales, ya sea push or pull, para saber qué es lo que está sucediendo con nuestro sistema. Esto lo hemos estado haciendo hace muchísimo tiempo. Lo que pasa y lo que ahorita necesitábamos es, tenemos más microservicios, tenemos más funciones asíncronas con diferentes versiones. Realmente no podemos tener un log porque no existe un tiempo lineal. O sea, las cosas están sucediendo en diferentes momentos, están sucediendo con diferentes versiones. Entonces, ahora lo que necesitamos es otra forma de primero, identificar qué es lo que está sucediendo y cómo está sucediendo. Por eso es lo que decíamos de traces con spams. Eso es, servicio A fue llamado en este momento, esta era su carga, esto era su payload, esto fue lo que hizo, etcétera, etcétera. Y con ello, o sea, cada quien nos manda la información, la consolidamos y después creamos. Fíjate, esto fue lo que sucedió en el frontend, esto fue lo que sucedió en nuestros proxies, esto fue lo que sucedió en nuestros servicios, esto fue lo que sucedió en nuestro backend, etcétera, etcétera. Y entonces es esta aglomeración de estas pequeñas mediciones que nos están contando una historia que estuvo rota por las mismas características de nuestro sistema. Y entonces vamos a necesitar diferentes estrategias y diferentes cercas de instrumentación de nuestros proyectos para obtener toda esta información. Ahora, el riesgo de lo que estamos tratando de hacer aquí es no pedirte que hagas más cosas. Por eso están saliendo muchos proyectos en donde tú dices, ¿sabes qué? Instrumentame esto automáticamente. Y por eso les comentaba, vayan a ver a OpenTelemetry, por ejemplo, para aplicaciones Java. Lo corren de manera interesantemente sencilla, pero por ejemplo les va a estar diciendo, cuando se ejecutó esto, hiciste una llamada a la base de datos, hiciste este tipo de query en un endpoint, etcétera, etcétera. O sea, hay ciertos momentos en las interfaces de los programas Java o diferentes frameworks que ya saben que es información que es importante reportar. Entonces, es de una manera de cómo hacemos para extraer más información y tratar de saber qué es lo que estuvo pasando a través de las diferentes exposiciones de información que tenemos. Y espero que te haya contestado ambas preguntas. Y ya se me acabó el tiempo. Por favor, contáctenme. Me apasiona este tema y muchos otros temas. Y espero que les haya gustado mucho mi plática. Muchas gracias.
Gracias, Ixchel. Bienvenida nuevamente a la JCOF Perú 2022. Y sí, todas las respuestas fueron absueltas. Gracias y bueno, esperemos que en otra oportunidad te podamos tener por aquí.
Placer.
Un gusto. Nos vemos. Gracias.
Hasta luego.
Bye.